how to work with the geometric
not that fast.
series.
Slow down a little bit. I'm going really fast.
So if the problem asks you to find the sum of a series, the only type of series that you know how to find the sum of is a geometric series. So you must be using the formula A of what the limits are. Okay? I feel like the geometric stuff is okay. You guys okay with that? Or
Yeah. What else do we have to do with the geometric stuff? Do error with it, right? Everything.
Error?
Can you do the error thing with it?
Yeah, we're going to talk about that when we talk about error. I don't want to get ahead of it.
The only thing is like realizing that it's geometric. That's what I know.
Yes.
So if it asks you to find the sum of it, it's geometric. Because that's the only one that you know how to find the sum of. So use that clue.
And that's how you find the sum.
That's how you find the sum. What's the A stand for?
The first term.
What does R stand for?
Error.
And you also will have to like write a geometric series in general. Like for example, if I have, I don't want to use the example that I did already. What is that?
1/3 yeah.
You can.
Or you can go 1/3 again, I guess.
Same thing. So now there's two ways to do this. If you wanted to do just that, what would n have to start at?
Three. 1/3.
No.
You're thinking it right, but you're not saying it right.
No, it has to be negative, right?
Yes. It would be negative, right?
Oh.
The other
I thought
way
it
to
could
do
only-
this is just say n starts at 1, or starts at 0, and then say 27 times 1/3 to the n. You just do that too. Which is probably the more straightforward way of doing it.
Sorry.
The next thing you have to be able to do is decide if a numerical series either converges absolutely. So what does that mean if it converges absolutely?
Convert to absolute value.
Converges with or without the absolute value.
Yeah, like you take the absolute value of a series and it converges. Or if it converges conditionally,
Does that mean it only converges if it's absolute value?
that means that if you take the absolute value of it, it doesn't converge.
No, it doesn't.
But if you leave the -1 to the n in there, that it does converge. So, like if you do the alternating series test and it works, but you do the ratio test and it doesn't, that's an example of a series that converges conditionally. Does that make sense? Or if it just diverges. Diverges, regardless of whether it's
Show us an example of converging conditional.
Sure.
-1.
So let's do. So one that converges absolutely would be like 1 over 2 to the n. Geometric series, we're multiplying by something that's less than 1 each time, multiplying by half, it converges absolutely.
But that's not really like one word even apply though, right? Because it's not an alternating series. It has to be alternating to even like bring that into effect, right?
No, I mean, it converges absolutely. Take the absolute value, it doesn't converge.
I think it's the same.
It is the same.
I thought that only applied to alternating series. Because that's the only time it's good.
No, like that's a valid question. Like if this could be the question, or that could be the directions, that could be the question. That's a
So
valid
that
question.
converges absolutely.
Yeah. It does not converge conditionally because it doesn't even have the opportunity to converge conditionally because there's no negative in it. One that converges conditionally would be the alternating harmonic series. If I take the absolute value of this series, it's the harmonic series which diverges. However, because it's alternating, it converges. This was real six.
Yeah, right? They have this
He said
in
they're
Bacteria now.
What?
They have those also. The matter at hand, the issue at hand.
The prompt.
I'll have to take care of that.
And
I'll
by
try
take
this
care
one.
of that, you mean
This is an example of something that diverges regardless of whether you take the absolute value or not. Here it has a -1 in it, but even if I take the absolute value of it or don't take the absolute value of it, it doesn't factor into my function.
So do we have to do some tests? That's what it seems like we have to go.
In one
No.
test.
Like, there, no. I mean,
No, wasn't there something with the alternating
Right,
series
this-
test though? Like,
How do we
if
know that
it
converges?
converges absolutely, then it converges, right?
yeah,
Wait, okay.
So
if
you
it
can do the
converges-
absolute series, like you can absolute value first, right?
Yeah.
So that way it converges, you say.
right.
Okay, this
So I
whole
think that answers your question. Before we get to that, hold up. So if I have a series that's alternating, try to prove that it converges absolutely. Like use the ratio test, or the root test, or the integral test, or one of those tests that requires that the terms are positive. If that comes out that it diverges, then do the alternating series test. And see if, what is the alternating series test?
Take out the -1, so you get the limit of what's left.
If it
Yeah,
converges,
take the absolute value of it, and you take the limit of what's left. So this is very easy. I don't have to do like the limit of the n+1 term or the n term. I just take the limit of that term itself. And if that limit is 0, then the series converges.
But if it converges absolutely, it converges normally, so
Yes.
that's why you're saying to the absolute value.
Right.
Okay.
Are we okay with this? This is where, this question is just like that quiz that we took. Remember that quiz that we took where like half of it was take home like a while ago? Half of it was take
Yeah.
home, we had like 4 taken questions, 4 in class
yeah,
questions.
actually,
That's like exactly, I'm just like taking 3 more questions. Not the same brain, but.
Wait, I'm confused.
Go ahead.
Oh,
I never
what
answered
would a
your
question like this look like? Like in what format? I'm like,
Those 3 questions. And you have to say, it converges absolutely. Do like the ratio test, or do whatever test.
wait, but okay, if you use the ratio test with one of these functions, then wouldn't you have to use another test to prove that it converges absolutely and not?
No, because the ratio test requires that you take the absolute value before you start. So the ratio test, you take the absolute value. If you prove it converges, then it converges absolutely. The only test that doesn't prove absolute convergence is the alternating series test. If you use any of the other tests, you have to take the absolute values first.
Or the
The
integral
absolute values.
test.
Without saying, sorry. Maybe that's why, maybe I didn't.
Please close this one first. Yeah, okay, this one first. If you have a problem with, say, like it's, 2 polynomials, right? Like 2 quadratic polynomials. Can you take just the first terms and take their limit? And then,
Like if you have the ratio of 2 quadratic polynomials and you're trying to
Yeah,
figure out whether that
just
stays
take,
convergent.
just the
Just
leading.
take the leading
Yeah,
terms, yeah.
now if they come out to be a constant, the series still diverges, right? Because you're adding a constant every single time. You know what I mean?
Yes,
So that's divergence. It
Yes.
only converges at 0.
yes.
Alright. So, there we go.
Okay, so now the third thing is you have to find, find a Taylor or a Maclaurin series. I didn't write that, obviously. You wrote it.
No,
I watched you write it up there.
you're lying because
you
wrote it.
Well, you're basically
No.
interchangeable. You're basically interchangeable. Right. So you
We're not
find.
interchangeable. I'm not in person, but still. The issue at hand.
Okay.
Don't make
So
wrong.
here, we're going to find the Taylor or the Maclaurin series and then use it to approximate a function. Okay. So this is.
I was like all that because
So now this part of it where you have to find the series is on the non-calculator part. The part where you have to use it to approximate a series is on the calculator part, which I realize is ironic because
It's the same problem.
what am I putting at you?
Because you love calculators, man.
Yeah. So now you have to be able to take the derivative of functions without a
Can
calculator.
you mention that they're easy derivatives?
yeah, like make it like e to the x.
Yeah, yeah. I really like that.
You get what you get. You don't get what you get.
What?
Where did that come from? How did you
She
get
said it all
that?
the time last year.
Delicious. Delicious. Good.
The only thing she said all the time last year was, "You guys got that?"
this formula.
Oh, that, yeah, I can do that.
What?
Oh, yeah. Create your X minus H, though.
You're right. So this is a Maclaurin series,
Oh, guess
meaning
what?
that,
I saw Gabby at the DMV this week.
okay, alright.
Come
This is
on.
for a Maclaurin series, meaning that I'm centered at 0.
Got it.
This, how would this change if it was a Taylor series?
There would be
X
minus
minus A.
So, now I'm plugging A in. Karen Tracy sucks eggs. Stop it, Yvonne.
Gabrielle, the Instagram.
Okay, stop. Stop, stop, stop. Yell, stop again like you did in 1903 and all that stuff.
1903.
You were born in 1903.
Yeah, the time that I
Is
was.
this alright?
Gabby's talking.
This is Maclaurin, this is Taylor. You have to be able to do both without a calculator. So just to be clear, you know that that like table where you know like the series for sine, e to the x, cosine, the ones we were just talking about? That only works for Maclaurin series. So if you know the series for sine and you want to find the series for sine not at 0, you have to rederive it.
Good.
Okay?
It's not 0, you're plugging in anymore.
Because it's not 0 anymore. So it's not as pretty. Alright, and how do you use it to approximate a function?
You just plug in whatever number you need to approximate.
Yeah, you just plug in, like if you want to approximate it at negative 0.2, you plug in negative 0.2 into the polynomial. Alright, then the next one is find the interval of convergence.
No, wait, sorry.
Go ahead.
There was a question on the review that said, does this over or underestimate?
Yes.
How do you do it?
You, like, actually need to find the...
Yeah, no, but it was like, it was one of those
Was
where
it
it
an
doesn't.
alternating series?
No, it didn't even give you the series. It just said, I believe it was number 55 in the review.
I don't even have it. We'll do that after.
Okay. I'm sorry, no. It was like, it just
She's
gave,
not even prepared.
it was one where it gave you like F, F prime, F, like, it didn't give you a series, it just gave you numbers.
Oh,
And then it says, is this over or underestimate? I'm like, what are you guys doing? I'll put it on the board. Oh, that is so.
we should look at whether or not those derivatives are positive or negative. Because then you can tell like the concavity of it. Does that make sense? We'll look at that. Let's look at that after we finish all this.
Alright, what's the one where you plug in the endpoints?
That's kind of where you said that's this one. So find the interval of convergence means that you have to find the radius of convergence using the ratio test, and then you have to like test each endpoint. Plug in the one endpoint, then test by using any test that you want. Plug in the other endpoint and test. Are we okay with that?
Are we going to do an example or no?
I'm going to give you a, I guess I should write this down for Kieran, and out loud.
What a loser.
She's listening.
I don't think she takes anything I say seriously.
Alright, then the fifth one is find error one of those 3 ways. The first way
Error.
is,
We need to go
I should
for
say
the
S,
large
error.
I'll take that.
Alter,
Well, first one's geometric, isn't it?
oh my gosh, that was so sad.
That was a good one. You should have done that.
Should have done that right into the microphone.
Well,
Yeah,
pretty sure the
I
first one's
had.
geometric.
still like opposite ends.
It doesn't matter, whatever, just listen.
It's fake. You just made it up.
Third. This one's third.
So, if it's an alternating series, what do you do?
Draw a smiley face for the first two.
Yeah, draw a smiley.
And not smiley for the next one. What a frowning. There's no frowning.
Wait, is that a mustache? Please tell me that's a mustache.
This guy.
No, they're just like, with the more...
Oh, geometric is happy too. Don't hate on the geometric.
Oh my goodness.
Now,
Dale?
right now.
That's on the back. Hit
No,
it.
wait.
Hit it with the eraser
What
side.
you do?
Here, spin your record. Go.
This is time wasting if I've ever seen it.
Okay, so what do I do for alternating series?
You have to basically find the next term
On the
and
next-
know that whether it's positive or negative. If it's positive, you're gonna like overestimate. If it's negative, you're gonna be like, I guess underestimate.
Yes.
Really overestimate.
Alternating series, you just find the next term.
So your error is next term.
Just find the next term, and you
Find
know that that's the
next
error.
term.
That's the error bound.
That's the error bounce. The error bounce.
Oh, that's the remainder thing, right?
That's the truncation error. They usually refer to that as the truncation error.
But it is R and of X, right?
Yeah, I mean, they're all that. They're all that. The more, I think that maybe you're thinking of Lagrange, I'm not. They're all, we're trying to approximate.
Registered nurse of X.
Geometric series, what do you do for the geometric series?
Find the next term.
No.
I have no idea.
A over 1
A over
minus
1
R.
is R.
Do A over
Duh.
1 minus R, where A is the next term.
That's what I said. You didn't let me finish. You have to find the next
That's
term.
not a term.
It's the next team.
That's R.
Wait.
M.
Next term as in the term after what you're looking for, or the second term of the series?
The
Term,
Oh, shit.
the first term that you didn't use.
Okay.
So if you use the X to the 5th term, then you start your A is the X to the 6th term. Okay, and then Lagrange, that's where you're finding.
Screw the garage. That's the
Look at Raj.
Can you put like
Boss
one of
is
those
the
on the
garage.
tops?
There's one.
I'll probably. Can you go over the alternate
Can we have that window?
and Lagrange because
Alternate, you just find the next term.
that's it.
Wait, actually
Yeah,
though, can we
have to
keep
find
that? Can you give us that formula?
Like,
You plug it into your reference phone.
I'm not going to give you that formula.
No.
Right.
I can't give you anything the AP test doesn't
You don't give me anything. I don't care about.
Wait, you just said earlier this isn't the AP test.
Does everyone just boycott the AP test?
No.
We paid for it.
Yeah, I guess that's.
We should boycott this test. I'm not paying for it.
I'm just making this up.
Yeah, it's true.
Wait, that's good.
But I would almost pay not to take it.
I'm just making this up. Okay, so here,
Get rid of that.
How did I feel?
so when n starts at 1, what's my first term?
X squared over.
Can we pay you to get the equation sheet?
It's x squared over 1. 2 minus 1 is 1.
It'd be negative X squared.
Yeah, you need two negatives there.
It is Monday.
Where's the negative? Oh, there.
Monday.
There.
N starts at 1.
Come here. Look who's
Karen's
that.
Oh, she's really forcing herself around.
Karen's not here.
Kieran. Monday.
Alright. So now x cubed over what?
3.
1
You want
factorial.
2 factorial. Oh, that's hard.
3.
Oh,
Why would it be factorial?
Where would it? I don't know.
We're just evaluating the series.
I don't know.
No.
I really don't know where we're doing this. What's going on?
just plugging
I'm just
numbers
plugging
into that.
He asked for an example of how to find an alternate series error. So if I use these first 3 terms, then, and I wanted to find the error, my error then would be the next term. My error bound would be the next term, which would be positive x to the 5th over 7. Then I would plug my number in, whatever that number was.
So what would the question be like for this? Find the error.
Find the error bound for the truncation error after you use the first 3 terms
So today,
for x equals negative 0.1.
And since that last term is negative, your error will be positive.
Last term's positive.
Oh,
well, it depends what you plug in.
because this term is positive, you will have like a full rest.
Oh.
Oh, what if you have like a negative number?
It's like okay. Little questions for you. Alright, so here are just 4 multiple choice AP questions that I thought would just help you.
Oh, BCPA. CCC. C1 equals CCC for all that.
Why are there division signs?
Is anyone going to speak here or no? They're not here.
He's at Monmouth.
Maybe I'll just email him.
Monmouth?
No, you
Yeah,
need
put it on
to
the Facebook page.
It's
so we can
on
all
the
watch
Facebook
it.
page. I'm gonna watch it later.
No, I know, but then this
Oh,
worksheet. I guess I could put both. Okay, so what I would like you to do now is spend a few minutes to try to do this all the process.
Are you sure about
Jack, what's next?
We're doing number 4. Kieran, sorry. We missed it.
No,
What's
what
the
I
next
said.
derivative? Jack, what's the next derivative?
Hi, Carrie.
Okay, Karen's back.
9.
Does he even know where this review thing is coming from?
No, but I'm gonna post it on Facebook. What's the next derivative?
27.
E.
Oh, I wrote F instead of 9.
I forgot that.
Why can't you just plug in 3x to this? Or
Yeah,
3?
can you just do like
You could do that.
Yeah, well, obviously can't.
I can't.
Okay, well, let's try it that way in a second.
Okay.
So now the third derivative is that. I want to plug 0 into that. If I plug 0 into this, I get 27. Right? So now that term, according to the general formula for a Maclaurin series,
Batman's pop.
x cubed over 3 factorial times the 27. Right?
Yeah.
So you just have to do 27 over 3 factorial, over 6. 27 over 6 is 9 halves.
Okay.
So the way that you did it was you used the series as e to the x equals 1 plus x plus x squared over 2 plus x cubed over 3. Factorial, sorry. So now you're plugging 3x in for x. You're not
Oh, so you have
multiplying it. You're plugging 3x in for x. So if I plug 3x in for x, it's 3x cubed over 3 factorial. And then it will-
Oh, shenanigans.
Yeah.
Okay, number,
We can do this.
do you want me to tell you all the answers now?
Yeah.
Yeah.
Go for it.
Number 1 is A. Number 2 is C. Number 3 is D. And number 4 is E.
I got those 3 right. I got 1, 2, and 3.
All fails.
No, there's no way. Rude.
Yeah,
So
I'm
you
gonna
wanna
fail
do-
this.
If you plug in
What's number
0.
2? Okay, regardless of anything else, if you look at number 2, like the second one is a harmonic series, right?
Yeah.
So it can't be D or E. Right? Hello?
What are we
Yeah.
doing?
Number 2, the second one
Yeah.
is harmonic. It's not alternating harmonic, it's just regular harmonic. That's like your most popular divergent series.
Got it.
Okay, so it can't be D or E. Now you just have to decide between A, B, or C. So the first one is just a P series. P is greater than 1, converges.
No, it's just B and C, 'cause E.
Now it's just, yeah. So now let's look at number 3. So that's alternating and it's geometric. So and you're multiplying by a third each time, right? So it works.
Question. This.
No, alternating will not always be convergent as long as the terms themselves.
Bye, Karen.
Wait, I'm confused. So, you know how like the BC
The
test,
terms themselves.
you know how like the BC test, you can get an AP score for it?
Good, hold on, let's not, you're getting off topic. Let's finish this real quick. Any other questions about this?
Let's do all this.
Any questions about these
Too
questions?
late to beg to get the test.
I don't know. Should it change it on
I
the
did it wrong.
Wait,
Are you gonna do another
One,
Miss
sure.
Doe, I have been trying to get the homework done, but you switched me at the last minute last week, and like I had to redo like 4 homework. So,
Kieran, if you're listening to this, it's your
give me
fault.
homework checks tomorrow.
You're going to fail this.
Begging you, it is.
Did you finish your fruit snacks?
In my village,
I hope you think of they healthy.
only best case scenario.
Stop.
Look, here's a